Now, let's take what we have learned thus far with one-dimensional arrays and with a dynamic one-dimensional array, and let's do an example. Let's do an application. I'm going to use the weather station data file, so let's take a look at that again. And here is the first part of the data file, and the column I want to look at is the precipitation. So you know we have a lot of columns, and I've just reduced the size of the window here so that we can see the precipitation on the far right. So if you get the data file and if you look at the PRCP column, then as you scroll down, you'll notice there are very few bad data items. Here are a few that are flagged as bad with negative 99.99, but most of them have legitimate real number values here, real measurements. And if it's March in Alabama, it could be snow, it could be rain. Regardless, it is precipitation. So what we want to do is to work with that column of data. Now, what do we want to do with it? Well, let's take a look at our goal, and I've written down some of the steps. So what we want to do in this example is we want to find the top 10 PRCP, precipitation values, that are in this file. And we know already that there are roughly 10,000 approximately data records in here. So we want to get the top 10 weather stations that recorded the maximum precipitation, or that we just want to we want to find how much rain there was in the top 10 weather stations. That's what I'm trying to say. Well, we know that we need to use the Alabama weather station data file, but how are we going to find the top 10 measurements of PRCP? How do we do that? Now, as your programs become more and more involved, it's going to be important to come up with a plan. You need to come up with an idea of how you're going to write the program instead of just diving in and starting to write code. So what I've done in this test case, or this case study here, is to lay out a plan. Now, let's look at the steps that we need to go through. So here is an approach, and it isn't the only approach we could take, but it is one that will work. And some things we know already. We know that we have to open up the weather station data file, and we've done that on several occasions, so we know how to do that. We can go copy and paste the code, in fact, for that one. And in this example, we're going to look at the precipitation column. So we need to know what column that is. So we can use the same technique we did to find Tmax and Tmin. We'll use that first line of the data file. And we'll look for PRCP with our find method, and that'll give us the column where the PRCP data begins. So we need to do that, and that will then be fed into our substring later on. Now, the next line in the data file is just a line of dashes, so we can just read that to get it out of the way. We're not creating a new file, so we don't need to write anything back out to a file this time. We just want to process the data from the existing original data file. I haven't declared an array, or I haven't shown you the code yet, but I'm not going to declare the array to begin with because I want to count how many good data items there are for PRCP. Then, when I know how many there are, I can use a dynamic array to create the array. So this means I don't have to guess at how many good values there are for PRCP. This program is going to find out how many good values there are, then it'll create a dynamic array. Well, how do we find out how many good values there are? Now, once again, this is the same technique we used for finding the good values of Tmax and Tmin. We'll have a loop, and the loop will read through the entire data file. So we'll read a line, then we are going to extract the column that contains PRCP, and we know we can use substring for that. And if it contains bad data, then it'll be minus 99.99, and we can test that as a string. If it's bad, then we'll just ignore the record altogether. Okay, we're not going to do anything with it. Then we'll just go back up to the top of the loop and we'll read the next data line. So we're just going to ignore all of the records that have bad data flags. If it is a good data item, then we're going to add one to a counter. So this will count up how many values are good for precipitation within the data file. This is one pass through our file of data. Now, once we have finished looping through, then we want to create a dynamic array for the PRCP data. And we can do that with the new operation. The data are real numbers. So you can see that if you look at the columns, we have real numbers here. So we want to make that either a double or a float. So I'm just going to choose to make it a type float. So once we know how many there are, then we can dynamically allocate the array here. Now, we haven't filled up the array, so we have to go back through the data file a second time. So to do that, we have to reset the data file back to the beginning, and we used our seekg function to do that. Then we go through the data file again, but this time we're going to load all those good data items into the array. All right, well, if we're starting at the top of the data file, we're going to repeat what we just did up here when we were looking for good data. We still have to go through the data file once again. So we want to read and ignore those first two lines. Okay, we don't need those anymore. We know where the column is for the precip, and we don't need the dashes. So we'll go through the same loop again. So I've got the loop indicated here, but instead of just counting the data this time, if it's good data, then we're going to convert it to a float. When we're using substring, then we get a string as a value, and if we want to save that as a float, we have to use our string to float function to do that. So we'll convert that from a string to a float, and we'll store the number into the precip array, and then we're at the end of the loop. So when we finish going through the data a second time, then we will have copied all the data from the file, and it will be stored in our precip array. So that's a lot of preliminary work to get what we really want. After we've done all that, then we have a sorting algorithm that we can use. Okay, so we could use bubble sort, we could use a selection sort. So now we know the bubble sort's not that efficient, so we'll just use our selection sort in order to sort those precipitation values, and then it's very easy. We just print out the top 10 precipitation readings. So that's going to be our approach. That's the plan. So it's a good idea whenever you're faced with a complex problem to lay out a plan for what you're going to do. Alrighty, well, now that we have a plan, let's see if we can convert that plan into code. Let's start with this code. And there's quite a bit of code here already, but then you've seen this in previous videos, so I don't have to just explain it in detail. One thing we're going to use is the selection sort, but I have made some changes to that. In the example we did earlier for the selection sort, this was a type integer, but we want to sort floating point values this time. We want to use a type float. So in my selection sort, I have changed the type from integer to float. The selection sort is already here. I've included it at the bottom, and you'll notice here that I haven't changed that from an integer to a float. The other thing I have to do is when I'm doing the swaps, I have the intermediate variable or temporary variable hold that I'm using. And if I'm going to have this variable to hold a value from the array, then it needs to be the same type. So I also have to have float hold instead of the integer hold that you've seen before. Now there's one other very subtle difference that I'm including here. Now, I want to sort the values in descending order. I want the largest values at the top. So I have changed this operator from less than to greater than. All right, so if the array value is greater than the array of the smallest index, then I change the array of the smallest. All right, now I'm not changing the names of that variable, but I could go back and say this is actually the index of the largest. All right, so I'm not going to do that. Okay, I'm not going to take the time to do that, but what I'm doing by changing this from a less than to a greater than is that I'm going to sort the data in descending order. The biggest number will be at the top, the smallest at the bottom. All right, so I've made those two changes then to the selection sort function that we've seen before. Now, let's go back to the top and let's look at what we have already. We have a string for the data line. We have our file pointer to read in the file. We have the string type for precipitation when we use our substring. And here's the position of the precip column. We had position of Tmax and Tmin before. And this integer for records is going to be the variable I use to count how many good records there are. Now the thing that I don't have up here is I don't have anything for the array precipitation data. So we're going to use a dynamic array. All right, so I'm going to need to create a pointer for that. So I'm just going to copy the code and I'll paste it in here. And let me clean that up a little bit. So I need to have a pointer to a float in order to make a dynamic array. So that's what I'm going to do here. All right, so now I'm ready to go. I have all the variables set up that I need. And now we can go through all the steps that I had in the plan. Okay, so we might want to look at those steps again. Okay, so here are the steps. So we need to open up the file, we need to find the position of precip, and we want to ignore the dashes, and we want to count all the good values. Okay, so what kind of code do we have for that? Or what code do we have for that? The kind of code C++, of course. All right, so you know how to open the data file. So we do that. You have to make sure it's stored in the right location. Then we'll test to make sure it opened correctly. Going through this quickly because you know how to do it. Then we'll read the first line from the data file, and here is our get line for that. Okay, and the example I have here, I'm going to print that back out to the screen, and I'll leave that in. You don't really need it at this point. So let's search now for the PRCP column in our first data line. Here's the code for that. We use our data line.find, and we look for the uppercase PRCP. And then, as we do with good programming practice, we want to use our if statement to make sure we find it. Okay, so if we do, we'll print out where it started. If we don't find it, then we have the error message. Then we move down, we read the second line from the data file. That's just a line of dashes. So we read that and we don't do anything with it. Okay, now we're ready to start counting the good data items for precip. So we'll get our first input data line, and I'm also printing that to the screen, but once again, you can leave that out if you want to. So now we are entering the while loop. So we want to pass through the data and we want to find all the good values for PRCP. All right, so once we know how many there are, we can make the dynamic array when we finish the loop. So let's put the code in here we need in order to go through the file and look for good PRCP data. So I'll paste the code in, and this is something that you've seen before as well. In earlier examples, we were taking care of the bad data for Tmin and Tmax. So in this time, we're just taking the precip values and comparing them we're testing them to see if they're good. Okay, so inside we want to pull out the substring for that column, and it's still a type string. Okay, so I'm storing it in the s_precip variable, so that's a string type. So that means I can compare with a string right here using the double quotes. So if the precipitation value is not equal to that, it's good, so then I'm just going to count it. And that's the only thing I need to do. I'm just counting how many good values there are. So then we'll read the next line and go back to the top of the loop and keep going till we're finished. When I'm done, I'll print out that there are that many good records in the data file. Then we can make our dynamic array down here. All right, well, let's go ahead and let's put in the code for the dynamic array, and then we'll just run our program to see if everything's okay up to this point. So we paste the code here, and it's a very easy, short line of code, but it's a very powerful one. So our loop counted the number of records, and there will be thousands and thousands of them, right? It'll be a big file. So then we'll create a dynamic array with new, and it's going to be a type float, and it will be as big as the number of good values for PRCP. Now we can use PRCP as our variable. That will be the name of the array, and we can treat that as if we had a regular static array. In other words, we can use the square bracket notation to get values out of it just as we would with a normal static array. Now, what do we have left here? If we want to reset the file and go through it again to load in all the data, then we'll need to use our seekg to reset the file to the beginning. And I like to always use clear as well. That just makes sure that access to the file is good. If there are any data error flags that have come up, then this will clear them. Okay, now let's wait about the rest of this for the time being. Let's just run our program and make sure that everything works up to this point. Now we have the output, and here it is. So we are good. We can open the file, and as a good debugging practice, you can print out some stuff to the screen to make sure everything's working. Then you can go back and remove it when you're ready to finalize your program. So this says that the PRC column begins at position 96. All right, so then we print out the dashes and we print out the first line of data, and we're good. So we get down to the point here, and look at that. There are 9,349 records with good precipitation data. So when we do the new operation to create a new array of floats, it's going to contain 9,349 values. So it's a pretty big array. Now, okay, things are working. So far, so good. So let's move on. Let's go through the file again, and let's load in the data into the precipitation array that we just created. Well, since we reset the file to the beginning, we have to get past those first two lines. So I'm just going to put a couple of get lines here. So the first one reads the header, the second one reads the dashes. So that gets us to the data. So now we will read the first line of data, and I'm going to use k as the index to index into the precipitation array. So now we're going to go through the whole data file again, and we'll copy the data into the array. So let's put the code in to do that. Let's paste that in here. And this looks almost identical to what we had before. We still have to extract the 5 characters from the precip column. We have to make sure that it's good. But this time, if it is a good data item, then we're going to take that string, we're going to convert it to a float with that function, and we're going to save it. We're going to store that data into our precipitation array, which we just created. Okay, so each time we go through, we'll increment k by 1. Okay, then read the next data line, keep going until we get to the end of the file. So that will copy the data into the array that we just made. Now we're done with the file. Okay, so we can close the file, we'll be done with it. And we'll be printing out some stuff coming up. So I want to set my manipulators for that. So I want to print out the precipitation data in a fixed format with a precision of 2. Now, we had the selection sort here. So we're ready to sort the data. The only thing we need to do then is to call the selection sort and pass the array in. So that's easy to do. We just call it. So this time we call selection sort and we send in the array. And since I used the index k as I was building up the array, then that's how many records I have. So that's how many numbers that the selection sort will be sorting. Once it's done, then we will have all those data items sorted. The precipitation will be sorted. So now let's just print out the top 10 values. And we can just do that with a simple. So I'll paste that in here. And I'll reuse k. So k will be 0 up to 9. And I'm just going to print out the sorted array PRCP k. And this is printing out 1 per line. Now let's run the program and let's see if we have reached our goal. Now we have the output. And let's look at the values that we get. Okay, so we know there are that many elements in the sort. So in this case, the selection sort goes through and it actually does this many exchanges, which is pretty good actually. Okay, so that's not bad for sorting that number of records. So anyway, it does the sort, and then here is the result. So there are the top 10 precipitation values in our data file. So this example then illustrated how we can use a dynamic array, and we can determine, or we can let our program determine how many values we have, and then we can use a dynamic array to store all the data. All right, well, the output from this was shown. Here it is again. The station that recorded the most rain recorded 3.2 inches of rain. But we don't know anything further about that. We don't know which station it is. We don't know what date that it was measured. So this does a nice sort. It does do a dynamic array, but when we sort the precipitation values, then they no longer correspond to the names. So let's bring the names of the stations. Let's bring our file back over. Okay, so here's the weather station data again. And I just used the find operation, the edit up here. I just did the edit, and I did a find, and I looked for 320. All right, so it turns out that the precipitation, 3.2 inches, was recorded here on March the 1st of 2018, and it was recorded at that station at Bridgeport. Now, what if I wanted to know the station names of all of those other recordings, all those other measurements? Well, I'd have to enhance my program quite a bit. If you want to do that, then there are a few different approaches you could take, but you can tell that you would need to include the other columns in the program as well as just the precipitation. Alrighty, so just a little bit more mention or a little bit more explanation for that before I stop. If we had additional pointers, or even if we had just additional arrays, then we could also store the station name, and we could store the maximum temperature. We could store any of those columns of data that we want to. But then when we sort them, what column do you use to sort them? If we use a precipitation, if we sort that one, then it'll be sorted differently than if we sorted the maximum or minimum temperatures. So there'll be, in the future videos, we're going to take a look at how we can find a way to process this data and bring in additional information instead of just one column at a time. Alrighty, well, I think that is sufficient for this particular video, so we'll stop right here.